How are you?
Good.
Am I good to go? All
Yes.
right. Hi, everyone. Welcome to CMU. My name is Steven. Like many of you, I'm also new to CMU. I'm actually a new faculty at ISR. I also have a affiliated appointment at MLD and MHCII. So my research at a very high level thinks about interaction between machine learning and people. And the type of interactions I think about can often be summarized in this oversimplified picture, where algorithms take in sensitive information about us and often inform and make decisions on people. So there are concerns, as in some of the safety issues in Amir's talk, that when algorithms so heavily rely on our data, they might compromise our data privacy. And when algorithms are making or informing decisions on people, such as hiring or loan approvals, there are concerns that there might be unfair discrimination or unfair biases against certain populations. So my research tried to address some of these emerging tensions between algorithms and society. And at a high level, there are two research questions, interconnected questions that drive my overall research agenda. So in the first one, I think about how we can make machine learning methods better align with certain societal values. For example, how do we protect people's data privacy? And how do we prevent unfair discrimination when algorithms are informing and making decisions? But building responsible algorithms is not just about protecting people. So it's the second question. We also think about how we can make machine learning methods more reliable and robust when they're deployed in complex social or economic environments. So here my work tried to address some of the frictions in machine learning in these environments. For example, people who are the input providers to these algorithms may have incentive to strategically manipulate their or misreport their data. And algorithms may engage in some kind of feedback loops in which an observation can only be made about a person when some consequential decision is made, such as granting someone a loan or hiring someone. So in this short talk, I will not go into everything. I will mostly highlight some of my recent work in the space of privacy and fairness. So let me start with some of my work in privacy. My work has been mostly focusing on a definition or framework called differential privacy. So I won't have time to tell you the formal definition, but think about a simple setting where there is a sensitive data set, say a collection of medical records. What we like to do is to have a privacy preserving algorithm that release some useful statistical information about the population, but not necessarily about any single individual. So for example, I might want to release a ML model or a collection of statistics so that no additional information about any single individual is leaked. So differential privacy is really a rigorous and mathematical way to capture that formal guarantee. So after well over a decade of theoretical study, there's actually a recent wave of practical deployments. Most notably, maybe some of you heard about this, the US Census this year is actually collecting some of the statistics with differential privacy. And a large collection of tech companies are also using differential privacy in their data analysis. So over time, more and more people are actually using differential privacy in their machine learning tasks or data analysis tasks. But a lot of them actually don't have the kind of training, formal training in differential privacy or even machine learning to work with the idea of differential privacy. So one really important challenge we care about is how do we facilitate this kind of non-privacy experts to work with differential privacy. So one approach our group has been taking is to think about, instead of releasing a collection of statistics or models, we directly release another synthetic data set. Okay, so think about it as a data set that consists of fake data records that look nothing like the individual data records in the original sensitive data set. But the data set as a whole actually preserves some of the important statistical properties. So what you can do is you can directly release the entire synthetic data set out in the world and allow different kind of data scientists, such as medical researchers or social scientists, to use it arbitrarily. So in this space, there's actually lots of interesting questions in theory. For example, you can ask what kind of statistical properties can you simultaneously preserve as synthetic data? There's also lots of interesting empirical questions in practical usage, such as in medical domain and social science, how well does this method work? So some of our collaboration actually reach out to medical researchers and social scientists to actually evaluate these methods. Beyond synthetic data, actually, I really like this area of private data analysis because there's actually a rich space of technical problems for those who are mathematically savvy. You can think about solving different kind of optimization and inference problems under differential privacy. And what I also like about this area is that there's actually lots of deep, interesting connections with other areas of theoretical computer science and machine learning, such as online learning and statistical validity. So just by working in this area, you can actually learn quite a lot about other related areas as well. So this is all I'm gonna say about privacy. So for the remainder of this talk, let me say a few more words about some of my recent efforts in fairness and machine learning. So unlike the literature of algorithmic privacy, there's actually not a agreement on definition of what algorithmic fairness should mean. So if you look at the fair machine learning literature, perhaps the most popular set of definitions or criteria or approach is this statistical group fairness approach. So roughly speaking, you try to train some kind of model, predictive models that equalize some kind of statistical notions, such as acceptance rate or false positive rates across different demographic groups. So these definitions are very easy to state and very easy to operationalize. So you can actually think about a large space of technical problems subject to these kind of criteria. But there's also fundamental limitations about thinking about this kind of statistical fairness criteria. They capture something about fairness, but definitely not everything. In particular, all of these criteria are based on observational data. So it takes a rather static view about the distribution. And in general, you should not view it as some kind of proof for fairness or unfairness. I view it more as a diagnostic system of a machine learning algorithm. And perhaps most importantly, we already know some of these maybe similarly reasonable notion of statistical fairness actually are incompatible with each other. So satisfying one means that you probably need to violate the other. So, so some of my work actually think about this space, but more recently, my group actually tried to think about maybe a broader view of fairness that sort of goes beyond this kind of observational criteria or just thinking about these algorithms. So let me give you two examples. One approach is actually directly thinking about a more dynamic view or directly thinking about feedback loop that the algorithm or the model engage in, right? So oftentimes we train a machine learning model that provide prediction that inform decisions, this kind of social decisions on people. And oftentimes people will react to these social decisions in certain ways and often change the underlying state of the world. And as a feedback loop, it also would change the kind of data you might be collecting in the downstream model. So there's actually a need to explicitly think about or model this kind of social dynamics and how unfairness might arise in this kind of pipeline. And one bonus, or at least a hope I really want to think about is, well, instead of taking this static view of machine learning, right, by taking this more dynamic view about the social dynamics, perhaps we can actually understand better some of the causal relationship across different factors. It's something we cannot do just by taking a more static view of the world. Another approach our group has been taking in taking a broader view is, can we actually explicitly think about capturing or embedding some of this social context in fairness criteria? So one example that allows us to do that is the framework of individual fairness that sort of go beyond the kind of group fairness notion I just showed you a slide ago. So for example, think about maybe we require the algorithm or the system to treat similar individuals similarly. So this framework is quite generic in general, but what is powerful about it is you can actually think about how to embed some of the social context in certain domains within the individual similarity measure of this framework. So we actually been thinking about how to actually effectively elicit or incorporate some of these social context through the framework of individual fairness. Another thing I want to highlight is actually there's a pretty interesting space between ML and HCI. One type of problems I really like to think about is to notice that oftentimes predictions are not decisions in many real world settings. Algorithms are often making predictions that inform human decision makers. So in the end, we really need to think about how human decision makers interpret these machine prediction in arriving at their final decisions. And perhaps while we're understanding this, we can actually redesign the algorithms with these kind of insights accordingly. So we are actually studying some of these questions in some of the real world decision support system. One of them is actually local in Allegheny County, the Department of Human Services, where they use predictive tool to assist child maltreatment hotline screening. We also work with Wikimedia Foundation that use machine learning to perform online contents quality control. And this is really a exciting collaboration with many faculty across HCII and also Hines. So with that, I would like to wrap up. All I want to say is there's actually a large space of problems we're looking at, and our group is also looking for new PhD students. So please keep getting in touch and feel free to talk to me. Thank you.